We're going to look at time value of money and the valuations. For time value of money, it really looks at how time and money are evaluated. But time is money. We've heard many people say that time is money. We're going to evaluate time in terms of money in these topics. So under time value of money evaluation, we'll look at the concept of compound and simple interest and how to calculate the future value and present value factors using the tables and also using formulas. So present value and future value simply denote the amount now is the present value. The amount tomorrow is the future value. So the present value is given by the formula 1 plus r to the power n. This is what we call the present value factor. Whereas the future value is given by 1 plus r to the power n, which is a future value factor. These are simply the future value factor and the present value factor. So to calculate a future value of 1,000 deposited now at an interest rate of 10% for 3 years. So we want to calculate the future value. So the future value, like I have alluded to, is given by payment now times the future value factor. So our future value factor, we have 1,000 as our payment, and the future value is 1 plus r to the power time. So if our interest rate is 10%, I'm going to multiply this one by 1.10 to the power 3. So the amount we're going to have after 3 years will be, what are you calculating?
The future value?
Yes, for the future value.
The 1,331.
1,331. So this is how 1,000 kwacha will grow to in 3 years. So question, what is the compound, what is the interest at that point? What is the interest?
What is
the interest? The interest is simply the future value minus what? The present value, how much we had. So we're going to have 1,000 minus what? 1,331. So the compound interest at this point is 331. So this is where we have a single deposit of 1,000, which grows to 1,331. So the interest is 331. Now, in the event that the 1,000 is deposited every after each year, starting from year 1, year 2, and year 3. It's not a single deposit anymore. It becomes what? An annuity. We have year 1, year 2, and year 3. So the term is what we call an annuity. An annuity is simply a series of equal payments that are made. If they're made at the end of the year, we call them an ordinary annuity. If they're made at the beginning of the year, it's called an annuity due. So if it's at the beginning, it's an annuity due. Now, annuities are applicable on a daily basis. For instance, if you're dealing with rent, which is paid at the beginning of the period, it's called an annuity due. We have quarterly insurance payments, which are paid at the beginning. Those are called annuity due. We have mortgage payments. We have retirement repayments. So those are examples of ordinary annuities. So if we're dealing with what we call a future value annuity, the formula becomes payment 1
Can you do this?
plus R the power n minus 1
Look at me. You can do this.
You
want
Let's.
So this becomes an annuity when the payments are made on a regular basis. So here we're going to have 1,000. Our interest rate is what? 10%. And our time is 3 years. So here we're going to have 1.10 the power 3 minus 1 over 10%. 1.10. So when you compute this, we're going to have 1,000. Then in here, we're going to have 3.310. So meaning, instead of having 3,000 after 3 years, we're going to have 3,310. So this is going to be called an ordinary annuity after 3 years, which is called a future value annuity. So when we multiply the answer by 1 plus R, the term changes. It is now called a future value annuity due. So here we're going to have 3310 times 1.10. The 310, 1.10. What are you getting?
$33,641.
33,
36,41.
641.
Yes.
So far, are we together? So you're seeing the difference between a single deposit that grows into a future value and a series of equal payments that are made at the end or beginning of a period. So those ones are called annuities. And when you multiply it by 1 plus R, it is now called an annuity due because now the payments are made at the beginning of the period. Conversely, present value is simply given by the payment 1 plus R, the power n. So the same amount, suppose if 1,000 kwacha is received after 3 years at an interest rate of 10%, how much money is this one worth today? If this one is received after 3 years, So we're going to discount it. You're asked to say, okay, do you want 1,000 kwacha now? Or 1,000 kwacha after 2 years? After 3 years, whose discount rate is 1,000. So to discount this one here, we simply use this formula. The payment, which is 1,000, over 1 plus R. So 1 plus R is 1.10 to the power 3. What are you getting?
Seven 51.3.
751.3. So this is called the present value, the value of this 1,000 if discounted today. In the event that you want to discount 1, 2, 3, a series of 1,000 kwachas, you are asked to say, can we give you a 3,000 kwacha today, or we split it into 3 years? What would you choose at an interest rate of 10%? So here again, the term changes now from present value to what is called a present value annuity, because there's a series of equal payments. So you divide this 1,000 over 1.10 to the power 1. Divide this 1,000 over 1.10 to the power 2. And you divide this 1,000 over 1.10 to the power 3. Already we have this one. This 1,000 after 3 years is not worth 1,000. Today it will be worth 571.3. How about the one you're receiving in 2 years? How much is it worth today?
It's 826.4.
And how about this 1,000 here?
It's 909.
Point what?
0.1.
When you add this, what are you getting? These three.
Two 404.
2487, isn't it? So you can also use a formula of present value annuity, which is given by the payment plus the annuity factor, which is 1 minus 1 plus R to the power negative n over R. So we have our payment here, which is 1,000. Then our interest rate is 10%, so 1.10, and our time is 3 years, so put negative 3 there, over our interest rate, which is 10. So 1,000 here, we have 2.487. When we multiply this one, what are we getting? 2487. So this is what we call present value of an annuity. So present value of an annuity due will become what? the present value itself times 1 plus R. So 2487 multiplied by what? 1.10. So this is called the present value of an annuity. Present value of an annuity. Now, interest is compounded annually. It is compounded semi-annually. It is compounded quarterly. It can be compounded annually is once, semi-annually is twice, quarterly is 4 times, monthly is 12 times.
Monthly.
Weekly is how many times?
52.
Weekly is 52. Good. So the implication of the number to compound is to add or end interest. So the implication of this is that the interest rate will always be divided by the number of compoundings. So these numbers are called M. And the time is multiplied by what? The number of compoundings. So the same payment we had of 1,000 at an interest rate of 10% for 3 years. So we're asked to calculate the future value. So if the compounding is more than once, the formula will just be multiplied briefly. We're going to have 1 plus R over M, then here M times time. So if we're dealing with quarterly, so we're going to have 1,000 here, 1 plus R, which is 10%. Okay, let me use semi-annually. Semi-annually means 2. So our M will be 2. So we divide here by 2. And our time, we put a 2 times the time here, which is 3. So the more you compound, the higher the value you're going to have. So here you're going to have 1.05, the power 6. Are we together so far?
Yes.
Rebecca, are we together?
Yes, sir.
Whereas the present value is simply, you can use the same formula, payment 1 plus R, the power M, the power negative MT. So the same figures here, we're going to have 1,000, 1.05 to the power negative what? Negative 6. That's the only difference because the present value will be smaller. Which gives us another important term, which is called the effective annual rate. The effective annual rate is simply given by 1 plus R over M minus 1. So 1, our R is what? 10%.
10%.
So the effective annual rate doesn't have a component of what? Of time. So this is where people have it wrong. So you get your answer, which is in decimal, and you can multiply it by what? By 100. What are you getting?
0.1025.
Okay, which is the same as what? 10 point what? 25%.
10.2.
Now this takes us to our last component of time value of money, which is called amortization. Amortize is simply to find the repayment plan for a loan. So if you're given a loan, amount of loan, which is the 1,000 kwacha, at this same rate of 10%, and that will be repaid in a period of time of how many? 3 years. Come up with an amortization schedule. So we'll start with amount here. Okay, beginning amount, and we got to the periodic payment, then we got to interest, then we got to repaid amount, how much you have repaid, and you go to the balance for the closing balance. So first thing is you need to calculate the payment. The payment first, you need to know this amount of loan should equal to the payment. Then here we have the present value annuity factor. So amount of loan is what? 1,000. Payment is what we're calculating. The present value annuity factor we know is 1 minus 1 plus r to the power negative n over r. So which we already calculated in the previous example. It was 2 point what? 2.487. Using the same rate so that we don't this is the amount that we found, 2.487. So when we divide 2.487 into 1,000, what do we have as our payment? What do we have as our payment?
We have 402.
Yeah, 402.
Mm-hmm.
This 402 is what we put throughout here. Because at 3 years, we've been given year 1, year 2, and year 3. So we'll be making a constant payment of 402. So our amount we started with was 1,000. Our interest rate is 10%. So 10% of 1,000 is 100. Then this one is simply column 2 minus column what? Column 3. So when we subtract these two, we get 302. And this one is simply column 1. So we can call this column 4. Column 1 minus column 4. So 1,000 minus 302. What do we get?
698.
So 698, this will be column 5 brought down. So we bring this one here, 698. Then we repeat the whole process. How do we get this column 3? Simply
10%.
column 1 times the percentage, which is column 3. So 10% of this 69.8. And how do we get this column 4? We subtract column 2 minus column 3. What do we get?
We get 2.2.
33, 2.2. Then here we subtract column 1 minus column 4. What do we get?
We get 5.8.
5.8. Anyone else? Where does this one go? It will be the opening balance here. And how do we get the figure here in column 3? Grace?
Multiply by column 3.
Percentage, which is 36 point what? 58. And here, how do we get this column?
We subtract
402
402.
minus 36, which is what? What do we get?
35.
Point what?
36. 5.4.
55.4.
0.4. Okay, 0.8. Such that when we subtract this from there, we get almost 0. That is what we mean to amortize the loan. We have paid it off. This is what we call loan amortization. Must balance the clauses. Not always exactly 0, but it goes to balancing off. This takes us to what we call bond valuation. A bond is a long-term debt instrument which is issued by a government or a corporation. Bond has the following features. Number 1, it has what we call coupon interest. Number 2, it has what we call a coupon value. Number 3, it has what is called a maturity value. Number 4, it has what is called a maturity period. Coupon interest is simply the interest earned on a coupon. So if a coupon is issued at 1,000 kwacha, maturity value is actually the face or original value of the bond, usually 1,000. Okay, and we're given 10% coupon interest. So the maturity or the coupon value, capital I, is simply a percentage, which is a coupon interest of the maturity value. So 10% of 1,000 is how much? 100. So this is a coupon bond which is earning a coupon interest of 10% in monetary value. It's got a coupon value, which is 100. The face value is the original price, which is the maturity value of a bond. Okay. It also has what is called a discount rate, a market rate. So a market rate, for instance, you could have what? 8%. Whenever the market rate is smaller than the coupon interest rate, we call this a discount bond. If KD, which is a market rate, is smaller than the coupon interest, we call this a discount bond because you're selling it at a loss. no, the premium bonds, because what is important is what? The coupon interest. If the coupon interest is more than the market rate, for the premium bond. If they're equal, for this what? A par. It's at par. It's a par bond. If the coupon interest rate is smaller than the market rate, for this a discount bond. So with the parameters given here, want to calculate the value of so the coupon value, since we're given coupon interest, 10% of 1,000, it is 100. Then the maturity value, already we have 1,000 there. So we've already learned how to calculate the value of the interest factor. Interest factor is simply 1 over what? 1 plus R or N, right? So what do we use for the interest factor? It's a market interest rate. The coupon interest is only used to calculate the coupon value. So 8%, so 1.08. The time is 3 years. So 1.08 to the power 3, what are you getting? So the maturity time is simply the period of time that the coupon, the interest, the bond runs. A period of 3 years would be a period of time within which the bond is running. If it's a 10-year bond and it's issued after 3 years, the period of time that it's running is 10 minus 3, which is 7 years. So what are you getting here?
0.793.
0.793. This is the coupon interest you put here. Then to get the annuity factor, we have 1 minus 0.793 over the interest, which is 8%, 0.08. What are you getting?
2.577.
Okay. 2.577. So the value, what are you getting in total? Add up, what are you getting?
$1,051.7.
1
1,051.
0 5 1
51.7.
point what?
7.
7. So since this amount is exceeding the par value, this is called a premium bond. If it was below the face value, the original value would have called it a what? A discount bond. If it was equal to, would have called it a what? A par bond. Now this same bond, if it is a semi-annual bond at the same parameters, the market rate is 8%, the coupon interest rate is 10%, the maturity value is 1,000, and the time in years is 3. So we say the interest will always be divided. So since semi means 2, our KD divided by 2, it will become 4%. Our coupon interest will be divided by 2, it will become 5%. So 5% times the maturity value, meaning our I will become 50. Since this multiplies, the maturity value remains the same, and our time will be multiplied by 2. This one will become N. The periods will be what? 6. The years will still remain the same, just compounding semi-annually. So this will be called a semi-annual bond. Semi-annual bond formula will still be the same. Maturity value times the interest factor. So our I here is 50. We'll calculate the annuity factor and the interest factor using the adjusted. So our interest factor is still 1 over 1 plus R to the power N. So since we're now using what? 4%. So here to be 1 over 1.04. The power what? Our N, which is 6. What are we getting?
Just 0.790.
Okay, 0.790. So this is the interest factor. Then how do you find the annuity factor?
Subtract by 1 divided by the interest.
Subtract it from 1 divided by the interest rate, which is 0.04. What are we getting?
Five point two five.
5.35.
25. 25.
25, thank you. So 5.25, what becomes the value of this bond?
To be 1052.5.
1052
52.5.
point what? 5. Awesome. Now, there's what we call the current yield. What we call the current yield, which is given by the coupon value over the value of the bond times 100. So this bond here is 50 divided by 1052.5 times 100. And a percentage, what are we getting?
You get 4.75.
So we get 4.75%. Now the current yield is actually an important calculation which finds or calculates the annual investment that the investor will expect to earn owner of the purchased bond. This calculates the intrinsic value of the bond. It's very important because it examines a measure of the current price rather than looking at the face value. It actually represents the return that an investor would expect to earn if the owner purchased a bond and held it for a year. However, we must also note that a current yield is not the actual return an investor receives if he holds it until maturity. So if an investor has a 10-year bond and he issues it afterward, after 2 years, and is selling the bond for 1,200, where the maturity value is still 1,000, and the interest rate is the coupon interest rate is still 10%. You're asked to calculate what is called the yield to maturity. Yield to maturity is simply given by the payment plus maturity value minus the value of the bond over n, everything over 2 times the value of the bond plus maturity value divided by 3. So payment here, the coupon payment is 10% of the maturity value, which is what? 100. Then the maturity value here, 1,000 minus 1,200. The maturity period is 8. So it's a 10-year bond, which was only issued after 2 years. So the period of time in class is 8 years. 2, 1,200 plus the value of the bond, or maturity value, which is 1,000 divided by 3. So this gives you what is called the yield to maturity, 6.6%. A bond may also have what is called a call premium, a call provision, which allows the bondholder to recall the bond even before it matures. So when it is recalled, it must have call provisions, and this bond is a callable bond. So you're able to calculate what is called yield to call. Those who purchased the pamphlet, I think I explained that in the pamphlet more. This now takes us to what we call stock valuation. The company has what we call ownership in terms of shares, which are owned by people called shareholders. We have 2 types of shareholders. We have what are called preference shareholders, preferential shareholders. So these ones have a fixed dividend in a return called a fixed dividend. Now this return is given to these speculative investors or the company at a predetermined time. However, they do not have any voting rights because of the nature of shares. the valuation of preferred stock is given by the value of preferred stock is simply given by the dividend paid over the discount rate for the preferred stock. We also have what are called the common stockholders or equity holders. These are ordinary shareholders. These ones are the real owners of business who have voting rights and residue. These are the real owners of a business. So they could earn more or could earn less depending on what residue has remained. So common stockholders have the following valuations. There's what we call the growth models. It's simply given by dividend over the discount rate. PO means the value of stock now. And there's what we call the constant growth model, which is given by DO1 plus G over KS minus G. This is the most common model. Now, because this is dependent on time value of money, I'll start explaining the constant growth model. When evaluating stock, we're just calculating the future values of what? Of dividends. For instance, D1 is equal to D0, 1 plus growth, the power at time, which is 1, the difference between these years. D2 is simply D0, 1 plus growth, the power time, which is how many years now? 2 years, because 0 minus 2 is 2. Using Gordon's model, the value of stock is simply what? D0, 1 plus growth over what? K minus G, where K is the discount rate and G is the growth rate. From here, you're able to tell that D1 plus D0 plus 1 plus G is simply D1. So other, right, I'll just leave it as D1, K minus G. So D0 means the dividend declared now. D1 is dividend declared after year 1. So you can even do D10 is the same as what? D0, 1 minus what? 1 plus growth power of 10. But the same D10 would simply be D9, 1 plus growth to the power 1. So the difference in years here is simply 1. We are told that a company ABC has just declared what? A dividend of 10 kwacha. Now, with a growth rate of how much? 8% and a market or discount rate of 10%. What is the value of stock? The value of stock is what? D0, 1 plus growth, the power time over K minus G. So whenever here has just declared a dividend, so here we're going to put 10 kwacha, 1 plus growth, the growth is 8%, so 1.08 divided by what? K minus G. Our K is 10%, our growth rate is 8%. So the value of stock will be 10.8 divided by 0.02. So what do we get there? 54. So 540. That is the value of stock. 540. Using the Gordon's model. But if the firm simply says their dividend in year one will be 10 quarter, with a growth rate of 8%, and we're told that the appropriate discount rate is 10%. Gordon's model has given you the value of common stock being as D1 K minus G directly. So here we're going to have 10 over 10% minus what? 8%. So this will be 10 over 0.02, which will give you 500 as a value of stock now. At this point, any questions before I proceed? Are we moving together? Henry, are we together?
Yes, but together, but the formulas are quite confusing.
The formulas are quite confusing.
Yes.
So we're using the value of common stock. We're simply giving us D0, 1 plus growth, then K minus G, where K must always be greater than the growth rate. That is the requirement. So the K is simply the appropriate discount rate, whereas G is a constant growth. And the D1 is the dividend paid at the end of year one. If it's D0, it has just been paid. So let's look at this example here. A stock, the required rate of return for preferred stock is 10%. The company pays 8.12 per year. What's the value of stock today? This is preferred stock. It's simply the dividend paid now over the appropriate discount rate. So 10% divided into $8.1, which is giving you 81.25.
1.25.
Then we're also told the firm just paid 1.82 at a 0 growth rate. And the rate of return is 16%. What is the value of stock? We just divide the dividend paid. There's no growth rate. This is a common stock. It's supposed to be K minus G. Even if you put G, which is 0%, it will still remain 16. So 16 into 1.82, it's 11.38. Now, here is a company that has a growth rate using Gordon's model. The company just paid a dividend. The growth rate is 10% per year, and the most recent dividend is 1.82. The required rate of return is 16%. What is the value of stock? So since we have D0, which was the recent paid dividend, so we're going to use D0, 1 plus growth to the power 1 to give us D1. So our D1 is $2. Then down there, we're going to subtract K minus G. Our K is 16%, our growth rate is at 10%. So 10 minus 16 is 6%. So divide 2% over 6%, which gives you 33.3%. This is ideally what I was explaining using Gordon's model. So ideally, we are doing 3 topics in one session. It's a condensed, but as I go through past papers in the session tomorrow, It will be based on these three.
These three what you covered. Okay.
Yes. I've simplified three topics in the simplest possible way I can. Now, there's a time when you have what is called a non-constant growth model, where you are given to say dividend paid now 10 quarter, and the growth rate is 10% for the first 3 years, year 1 to year 2. And thereafter, it will drop to the growth rate in the second phase. It will drop maybe to 5% from year 3 thereafter. So with given that the market rate or the discount rate is 15%. So you're asked to calculate the value of stock now. So we're going to use a number line. So we just declared year 1, year 2, year 3. So we have 0 here, 1, 2, 3, 4. So we started with a 10 quarter, and the growth rate for the first phase is 10%. So in year 1, what becomes the value of dividend in year 1? So we know that D1 is what? D0, 1 plus growth. So we started with 10 quarter, and our growth rate for the first phase is how much?
10%.
10%. Good. So we're going to have 1.10 to the power 1. So here it's going to give us 100. It will be 11 quarter. That is our D1. Together, this
Yes.
will be 11 quarter. So we go to D2. Who wants to lead us? How do we get D2? D0, 1 plus
As
growth
G
to the power what?
power 2.
2. 10, 1.10 to the power what? 2. So this will be 10, 1.21. So this will give you 12.1.
12.1.
Or the easiest is just multiply the previous dividend times what? 10% times 1.10. If it was 8%, 1.08. So you had 11, you multiply by 1.10. You get the same answer, 12.1. Get the next one, just multiply by 1.10. Okay. This is for year 2, year 3, year 4. The shortcut to doing just multiply the answer by the interest rate plus 1. Just multiply by 1 plus R. So here we had what? 11 multiplied by 1.10, you get 12.1. Year 3, 12.1, you multiply by 1.10, what are you getting? E3, what are we getting?
13.31.
13.31. Okay, then year 4, 13.31, you multiply by what? 1.10.
14.64.
What are you getting?
14.64.
14.64. Okay, so this will make your life very easy. So this is 12.1. This will be 13.31. And finally, this will be 14.64. So we're interested in phase 1. So for phase 1, we now want to calculate the value of stock for the first phase. So remember how we're calculating the present values under time value. Want to know how much these values are using the market rate. So we'll discount these ones here. So this will be 13.31 over 1.15, which is 15%, to the power 3. What is the value of this one? 12.1 over 1.15 to the power 2. Then 11 over 1.15 to the power 1. Let's calculate all these and add them up to get the value of stock for the first phase. So the 11 becomes how much? Eleven becomes what?
9.56, 9.57.
9.57. Then 12.1 becomes what?
It's 9.15.
9.15. Then 13.31 becomes what?
8.74.
8.74. So when you add these three, what are you getting? Don't add the 10. This was just helping project these three.
27.6. 27.46.
7.46. So this is the value of stock for the first phase. Now, for the second phase, here we use Gordon's model, which simply says the value of stock is simply equal to D1 K minus G. So this is our D1 here. We want to take it to the value of stock here at year 0. So since this is our D1, we'll divide it by our K, which is 15%. But the growth rate for this second phase, we're not using 10%. We're using what?
5%.
5%. So 0.05. What are we getting? So 14.64 over 0.10.
I'm getting 146.4.
146.4. Then since this is as at year 3 here, we want to also discount this one to find the value that it has. So we're going to divide this one by 1.13 to the power 3. Find its value here. 146.4 divided by 1.15 to the power 3. What are we getting?
96.46.
And 6.06. So when we add this,
96.26. 26.
when we add this and that, what are we getting as a value of stock?
123.7.
123.7. So this is how we find the value of stock. A recap, we started with a 10, which was used to project the values of stock for a 1, 2, 3 up to 4. Then for the first phase, since the growth rate was 10%, we discounted them using the 15% to find the value of stock for the first phase. So we found 27.4346. And this is our D1. We have to, using Gordon's model, find the value of stock now. And now it's in year 3. So we got 146, and we discounted it using the appropriate discount rate at year 3, which we found as 96.26. And when we add these two phases, we get the total value of stock, which is 123. So this is similar example here. The company has a required rate of return of 16%. So this 16% is our discount rate. The growth rate for phase 1 is 30%. For the first 3 years, it therefore drops to 10% for growth for phase 2. The most recently paid dividend is 1.82. So like I said, 1.82, you are finding the dividends for D1, D2, D3, and perhaps D4. So for the first phases, it has given you the dividends for the first 3, and also you can find for year 4. So D1, D2, D3. Like I said, it's quicker. After finding the first one, just multiply by 1.30, 1.30 to just get the next one. After you're done with that, which are the figures we got here, you now discount them using the discount factors. So for year 1, after finding 2.366, you discount it by the discount factor, 2.366. This is supposed to be 2.366. The discount factor here will give you the dividend in year 1. And here the second one is 3.076. Discount it, give you 2.286. And finally 3.99, you also discount it. The total here will give you the value of stock in the first phase. After finding the value of stock in the first phase, you use the dividend in year 3, which is 3.99, to calculate the dividend in year 4. Here, you can simply multiply this one by 1. You can use the new growth rate of 10%. Then you discount it by first finding the value of stock, then discount it backwards by 3 years, as at year 3 you discount it backwards. So this is how you calculate the value of stock. You go through the pamphlet and you see how the computation was done. So I've just noticed one thing. As of year 4 here, we actually were supposed to multiply not by 1.10, but this answer by 1.05, because the growth rate has changed from year 3 to year 4. So 13.31 will give you a slightly adjusted figure. But get the concept, because we are moving from year 3 to another phase. So just make that adjustment as you do your workings. Is that clear?
Yes.
Yeah.
Sorry, could you just repeat on the adjusted figure? I think I don't get that clearly.
So for us to get 10 to 11, we just multiply it by 1.10. 11 to 12.1, we multiply by 1.10 because 1 plus RI, this is 10%. So 12.10 to get to 13.31, we have to multiply this one by 1.10. But to get 13.31, we don't multiply by 1.10, we multiply by 1.05. What's the actual figure? 13.31 times 1.05, what are you getting? Yes, Henry?
13.97.
13.97.
97.
This adjustment because we are now moving in a new phase where it declined from 10% to 5%. Then now we use Gordon's model to adjust now 13.97, 15%. This one becomes 139.7. 109.7. Then we discount this at a discount rate of 15%. What are we getting? 139.7 over 1.15 to the power 3. What are we getting?
9.19.
Pardon?
9.19.
Are you sure? 139.7 divided by 1.15 to the power 3.
Oh, 139.7. Divided by
91 point
91.85.
85. Then now we can add this plus that. What do we get?
119.3.
So this is a value of stock. Any questions?